Okay. All right, so the first problem, we are multiplying a 2 by 2. So we're going to set up a 2 by 2 box. 2x goes here, negative 9 goes there. X goes here, and a positive 3 goes there. How'd y'all do? Okay, remember, when you first fill the box in, that's when you're adding powers. So this first box is 2x squared. This should be 6x, not 5x, 6x. We're multiplying. This is negative 9x, and this is negative 27. How'd y'all do there? Okay, and then this is your answer, but y'all, we can clean it up because adding powers now. This is a negative 3x in the center. And then minus 27 tacks on the end, and 2x squared. There you go. 2x squared minus 3x minus 27. How'd y'all do? Nice. Spiral back to something you're going to need to know. Those were the steps. Distribute. We do not want to be afraid of fractions. In Math 1, y'all, a lot of times when you're distributing a fraction in Math 1, the fraction will go away. Now, when you get in some higher level, so y'all, basically what this is, I'm gonna say it two different ways. This is 1/2 of 8. What's half of 8? Do you see that? Okay, another thing is, we're multiplying, y'all, 8 is on top, 2 is on the bottom. Can you see that? 8 divided by 2 is 4. So that's 4x. Yes, Aldo. Okay, 1/2 of 20. What's half of 20? Do you see that? But check this out. 20's on top, 2's on the bottom. What's 20 divided by 2? 10. Still 10. So y'all, we can't be afraid of fractions. We cannot be afraid of fractions. We got to die. Else down. What's the next step on the board tell you to do? Combine like terms. 4x goes with negative 2x. What do I get when I combine 4 minus 2? 2x. Positive 10 and positive 8 can be combined to get positive 18. Bring down your equal sign, bring down your negative 4. Y'all, the reason why I put those steps in that order is because if you do it in that order, all of a sudden you have a 2-step equation from 7th grade. So now we subtract 18 on both sides. We get 2x equals negative 22. When I combine, that's negative 22. And my last step is to divide by 2, and I get x equals negative 11. How many people got that? Okay. Y'all, the rest of us, we got to know how to do this. This is from first quarter. Okay. Okay. All right. Y'all, this, we definitely, everybody needs to be paying attention. If you're doodling, we might want to stop. I can promise you this is going to show up on your quiz or your test. It's not hard. We may have done one or two. I don't know. Okay, so here we go. First of all, rectangle. One. Rectangle. The length is x minus 2. The width is x plus 5. It's asking me to find what? Okay, can somebody tell me the formula for the area of a rectangle? Length times width. So would y'all agree we're multiplying? Okay, check this out. Length times width. Do y'all recognize that kind of problem? It's just like number 1. They made it a rectangle problem. It's just like number 1. It's an area. Okay? By the way, this whole setup, that 2 by 2 box, that actually has a name. It's called the area model. because it's about finding the area. Okay, so check this out. X plus 5, there's your X and your 5. X and negative 2. So those boxes are area models. When they say find the area, that's what you've done. So we got X squared, 5X, negative 2X, and negative 10. And then I combine the middle, and when I combine the middle, I get a positive 3X. The answer was B. How we do? Did anybody get it? Nice. Okay. Okay, now we're going to change things up. There's a keyword number 4. What is it? Perimeter. Most of y'all remember. You're adding up all the sides. Well, let's draw this bad boy. I have a rectangle. The length is X plus 5. The width is X minus 2. Have I left anything out? I have. There's another length over here that's X plus 5. There's another width over here that's X minus 2. For perimeter, add them up all the way around. So what is 1X plus, not times, plus 1X plus 1X plus 1X? 4X. It's 4X. What's 5 plus 5? Minus 2. Minus 2. It's 4X plus 6. Did anybody get that one? Okay. I might put some on a warm-up or something, okay? We good? Okay, so we're going to put this away. I want you to take your yellow slips and let's push them up to the top, and I want you to get your binders out. Okay? And y'all, as usual, need to make room. We need to make room. Go ahead and open that bad boy up. Don't worry about where to, just get it open. Open that bad boy up. Okay. Yeah, it's just a little tricky getting back in the groove of doing this. Usually pretty good about flipping back and forth and getting the videos going. Now I've forgotten most of it. Okay, so here we go. All right, so folks, again, you picked out your end behavior for these, but I want you to still watch what's going on. I might have glued these, you know what I mean, wonky. Okay, y'all, this way is when X gets bigger. Where's your graph going? Where's your curve going? Up or down? Up. It's going up, so Y is getting bigger. When X gets bigger, Y gets bigger. Okay, now let's look over on this side. Y'all, this is where X gets smaller. Where's Y going? Where's your graph going? Down. So when X gets smaller, Y gets smaller. So that goes right there. As X gets bigger, Y gets bigger. As X gets smaller, that goes right there. Okay. All right, let's go to this one. Okay, it kind of ends, but X is getting bigger. Where's Y going? Down. X gets bigger, Y gets smaller. This side, X gets smaller, Y gets bigger. So that's this guy. X gets bigger, Y gets smaller. That's over here. X gets smaller, that's over here, Y gets bigger. Okay. All right. Let's go to this guy. Hopefully you noticed something kind of like, whoa, what's going on with this? Okay. Some of this is about the same. Over here, make sure you're on the right graph. Make sure you're on the right graph. X gets smaller. Where's Y going? Up or down? Y gets bigger. See, it's going up. Okay, now here's the weird part. X gets bigger. What's going on here? X gets bigger. Is there an option that makes some sense? It's really not going. Y'all, it's getting closer to zero. Y'all, it's getting closer to zero. And it's just going to hover right there. Bigger, this approaches zero. That's called an asymptote. And by the way, they happened with those guys right there. Okay? So here we go. That goes there. X gets bigger. This is approaching the zero mark. Anybody? Okay, so let's look at this one. As X gets bigger, where's Y going? Up. So as X gets bigger, Y gets bigger. Now here's the weird part. When X gets smaller, what's going on? This is one of your options. Y is approaching 1. It's approaching this 1. So that goes there. But not least, first of all, make sure you're on the graph that's opening up. Make sure you're looking at the right graph. Okay. X gets bigger. Where's the graph going? Up. X gets bigger, Y gets bigger. X gets smaller. Y gets bigger. So y'all, the right-hand side of your slip is going to say bigger, bigger. It's going to say bigger, bigger. Bigger, bigger. At the very end of your slip. Okay, now let's come over here. X gets bigger. Where's Y going? Small. Y's getting smaller. X gets smaller. Where's Y going? Smaller. Smaller. Hey, y'all with quadratics, look. Smaller, smaller. Y gets smaller. Y gets smaller. Y gets bigger. Y gets bigger. That's the way the quadratics work. Okay? So there's that, and there's that. And now we want to make sure that we glue these as far up as possible to leave ourselves as much room as possible. If you didn't, you'll find a way to fill it in. It's okay. Okay, so let's go ahead and glue. Yes, ma'am. You'll have to, if you'll just look up here. You can look on the end. That's bigger, bigger. That's smaller, smaller. Okay, I just loaned my glue stick out. So now I don't, this one. Yeah. Somebody, is anybody, well, I don't want to steal hers. Is anybody finished gluing? Oh, you got, it's an extra. Y'all, I would glue it as far to the underneath the graph as you can. You want to save as much room as you can. And if you trimmed them up correctly, they should just fit side by side with no problem. If you trimmed them up. Did you see that one? Yeah. Bigger, bigger, smaller, smaller? Yeah. Okay. Exponential. Y'all, exponential, look how weird this end behavior is with exponential. Y'all, exponentials taper off and approach something. So, see that, we were talking about distinguishing between graphs, so that's what I'm trying to get you to see. Notice with quadratics, it either gets bigger, bigger, or smaller, smaller, the y. The y's are either both going up, or the y's are both going down. Okay, but y'all, with an exponential, it's literally gonna taper off in this direction to a number, or taper off in that direction to a number, with an exponential.
What happens above backflip? What do you do?
Okay.
First one is as X gets bigger, Y gets bigger.
The one back here with the linear. Notice x gets bigger, y gets bigger, x gets smaller, y gets smaller. I don't want these glue sticks.
That's it. Motion?
All right. Okay, so y'all, I'll say it one more time. We are comparing three graphs, three different functions. That's the reason why we've got these notebooks. So you really need to take a look at how all of these end behaviors are different. Y'all, these approach a particular number either over here or over here. Exponentials. Y'all, quadratics always, the y's are either both going up or the y's are both going down. That's how this picture looks. And y'all, look at these lines. One y value is getting smaller. One y value is getting bigger. On the other side, the y value is getting smaller. This is linear. So y'all, look at the difference in those. Okay. All right. All right. Next thing we're going to do. First of all, these are not cutouts. And what I've done, these again are characteristics of these graphs. They're characteristics of these graphs. Answers on here, and you have to figure out which ones go under what. Okay, you're not cutting, you're not pasting. This is your answer sheet for you and your table partner to look at and determine what goes where. Okay? So put this in the center of your table. When you use one of these and figure out where it goes, you can check it off. Okay. I'm going to use them again. Okie dokie. Again, most of this should on a graph. We should know how to find a y-intercept on a graph. Okay, maximum and minimums might be new to you, but I bet if you took a peek, you could figure it out. Okay? I'm going to put 5 minutes on the board. Anybody got a question? We good? Okay.
Because
Yes, sir.
because I mean, everybody. I don't know. All I know is the first one goes to the second one on the first page, and the second one goes to the one.
So are we just figuring out like what's
I don't know.
No, you're supposed to be doing something, Maddie. Do y'all need to go up to the office, take a break? What? You're laughing when you're supposed to be doing activity. Do you need to go to the office and take a break? No. Okay. You shouldn't be. You should be doing what I asked you to do. If you're feeling very confident about your answers, and by the way, y'all, some of y'all look at me like you're crazy. I know y'all know how to find an x-intercept on a graph. If you don't, you have literally tuned me out. If you're confident about some of it, you need to go ahead and write it down. But y'all make sure when you're writing it down that you're just not like writing in big letters. I mean, just try to form fit it. She asked, and I said, if you're feeling comfortable with it. Y'all, these you should feel pretty comfortable with. You should feel pretty comfortable with finding the x and y intercept on a graph. I'm just saying, so y'all can probably write some of it. Let's see. I guess if I had to give an example, don't forget that this is your x-axis. So right there's where the graph crosses the I'm just saying, some of y'all still kind of staring into space. That's your x-intercept right there. All right. If you want to just put a dot beside of it that you've used it, you can do that. It's fine. I'm going to try to reuse them though. Okay, I'm going to start with my linear graphs again, make sure you're at the right one. We should know maybe from last semester that the where the graph crosses the x-axis, that's our x-intercept. Here it is -6. Did we know that? We should. Okay. What's y-intercept? Where the graph crosses what? The y-axis. Well, here's your y-axis. Where does the graph cross the y-axis? 3. Okay, also, we want to keep in mind, how do we write that as an ordered pair on the graph? Something, comma, something. Okay. I love your answer, but no. The 3 represents here, and the -6 represents here. How would I write that ordered pair? -6, comma what? 0. In contrast, and be careful who thinks they can help me write my y-intercept, my ordered pair for my y-intercept. It's right there. What's that ordered pair? 0 comes first, then the 3. So y'all, if you remember, x-intercepts are where y is 0. Y-intercepts or where x is 0. So y'all remember, you got to know how to write them both ways. Okay. Okay, so let's go to this little guy here. My x-intercept is right there. It's at -2. My y-intercept is right here. It's at -6. Is that -6? Okay. How do I write my x-intercept as an ordered pair? Like, in other words, what's that ordered pair? Right there, where my pen is. -2, 0. And this is my y-intercept. What's that ordered pair right there? 0, -6. Just trying to remind y'all about some 8th grade math stuff. Okay, and at the end, I'll show each one of these again. Okay, let's do the weird one. Okay, first of all, there's one of these, it's easy. It's the y-intercept. What's the y-intercept?
Oh, shoot, I'm sorry.
Right here is where it crosses the y-axis. What is that?
2.
That's 1. Okay, so did anybody figure out what goes with this? Okay, y-intercept 1, what else goes with it? No x-intercept, because y'all, if you look, does this cross the x-axis? No, it does not. No x-intercept, and which one goes with what? Well, the one that's got where it gets to 0 has an asymptote at y = 0. Okay. So notice this comes all the way down to 0. So no x-intercept, asymptote at y = 0. Y-intercept, we should be able to pull it right off the graph. It's at 1. All right. Okay, so for here, we should be able to pull our y-intercept right out. What's our y-intercept? Y-intercept's 2. Do I have an x-intercept? Does it cross this axis at all? No, it does not. So no x-intercept. There's an asymptote. And by the way, all of this is on your sheet if you're trying to figure out how to write the stuff. It's on your sheet. Asymptote is y = 1. Your y-intercept is at 2. Okay? And somebody asked in the last class, and you should ask, because asymptote is a new word for you. What is that? Well, y'all, what an asymptote is, and you're going to do more of this in Math 3. We just introduced you to it in Math 1. But y'all, what an asymptote is, it's like an imaginary fence or boundary line, and the curve never touches it. So if you look right here, there's an imaginary fence at 1. And the graph will never touch it. That's an asymptote at y = 1. And remember, horizontal line is y = 1. Okay, over here, we got a fence right here now. That line is y = 0. It's going to get closer to 0 and never touch. And notice they're using y equals. They're using y equals for the asymptote, not x equals. Okay. Okie dokie. We good? All right, let's go to this last quadratic. Okay, did anybody notice anything funny with the x-intercepts? Like, what x-intercept we have here? X-intercept. You have 1. How many x-intercepts we got here? Y'all, do you see the difference? Do you see what I'm saying? Look at your quadratic. It's got 2 x-intercepts. And look at your linear, it's got 1. See, all of these are little bitty differences between these 3 different functions. Okay, so here's my x-intercept here. Here's my x-intercept here. So x-intercept, there's 2 of them. It is -2 and +4, is that right? Yeah?
Yeah.
Okay. Y-intercept is -8. Okay, here, this is my x-axis. I've got 2 x-intercepts. X-intercept here is -5. And my y-intercept is what? Y-intercept's up here. What's my y-intercept? Thank you for somebody pulling us through. Y-intercept's 15. With quadratics, you had 2 x-intercepts. That's not random, y'all.
Unless you knew.
With linear, you only had 1 x-intercept. That's not random. That's the way it works. 2 x-intercepts. With linear, you got 1. Notice the weirdness here. These particular graphs for our exponential don't even have x-intercepts at all. Do you see the difference in those? Okay. All right. Y'all gonna do something else. It's gonna be a little hard. Okay, so now we're going to do increasing, decreasing. Again, most of you guys are lucky. We've done increasing and decreasing in this class. Some of y'all may not remember. Okay, so you have 6 graphs. Remember that when we're doing increasing and decreasing, we're always driving from the left. Okay? So I am going to put up your options for your answers, and you figure out which ones go underneath your graphs. Okie dokie. This one is decreasing everywhere. I'm just going to write D-E-C-R. Okay. And I'm going to come back to these at the very end. Okay, here. What is this one? It's decreasing everywhere. Okay, now with an exponential, when it's decreasing everywhere, last semester we learned a fabulous word that goes with decreasing everywhere for exponential. Somewhere hanging up in this classroom. Decay. We use the word decay with exponentials. Okay, how about this one? It's increasing everywhere. What is the word we use for exponentials? Growth. Good job.
Okay.
All right, and like I said, I'm on. Okay, these are the ones that increase and then decrease, or decrease and then increase. So check this out. This little guy right here, he changes right there, doesn't he? Doesn't he change right there?
Yeah.
Okay, well, this guy has a name. He's a vertex. You might want to write that. And that ordered pair is 1, -9 is that ordered pair. 1, -9. So before we get to 1, on this side, it's going down. After the 1, where x is greater than 1, it's going up. Okay. So decreases, D-E-C-R, when X is less than 1. Increases when X is greater than 1. And notice, right there's where it changes. It changes right there. It goes downhill till it gets to 1, and then it goes uphill. And you got a vertex at 1, -9, and I do realize that that's a new word for you. So let's absorb it. The vertex is where the graph changes from increasing and decreasing. By the way, is this the lowest point on the graph or the highest? It's the lowest. That's called a minimum. Minimum is the lowest point, right? The lowest point is -9. That was on your sheet. Minimum is -9. Do you notice how the minimum is the y part of that? Do y'all see that? And your increasing, decreasing is pulling the x part of that. All right, and the last one. It's increasing until we get to that guy right there. Then all of a sudden it starts going back downhill. Well, that little fella has a name. He's called a vertex. And what is that ordered pair? It's the ordered pair -1, 16, I believe. Is that right? So before the -1, where x is less than -1, it's increasing. And then after that, it's decreasing. So increasing when x is less than -1, decreasing when x is greater than -1, and then let's write our vertex down. The vertex is where it switches, like the top of the roller coaster or the bottom of the roller coaster. That's the vertex. That's the way I think about it. Bottom of the roller coaster or the top of the roller coaster is the vertex. And then, by the way, is that very tip top, would we call that a maximum or a minimum? We call it a maximum. And y'all, how high is the y part? The x part doesn't tell you how high. The y part tells you how high. So your maximum is 16. Okay? Now, what I'm going to do is I'm going to leave this right here for a minute in case you didn't get something. And then I'm going to slide, then I'm going to slide. So if you missed something, it's right here. While y'all are doing that, I do want to tell you, don't forget, I will be posting this video. So if you're like, boy, she covered a lot today, you can literally go back and hear me say this. Okay? Okay, I'm going to slide to the middle. This, Miss Batchy. Yeah. Okie dokie. Bye. Taylor, I think you have early dismissal. Okay, so here's the middle. By the way, if you didn't get this, where can you go? You can go into the video and finish it if you need to. Should be posted. Okay. I want to tell you how to close this. So. Okay, and here's the linear. Is there anybody that needs to write anything for the linear? Okay, so remember how we close this, folks. I would just close one end, close the other. Good job today, y'all. Good job. That's it. That's it. And we have 7 minutes left of class.
Are you going to start the recording?
Oh.